so let's go ahead and get started. So today we're going to go ahead and identify central and inscribed angles of a circle. Now, I hope yesterday you guys watched the video. You guys were able to identify what a circle is, how to define it. Ms. Vasquez, can I copy this down? You guys had the video posted on Canvas, so you guys can go ahead and copy down the notes from that, okay? So I hope you guys had enough time to copy that yesterday. I asked you to take notes from the video. So I asked you yesterday to copy down the definition for a circle. Basically, it's the locus of points in a plane that are fixed from the distance from a given point. So here's my center C. And basically, any point that is equidistant from that point is going to be creating a beautiful circle. Now, next items, guys, we had interior and exterior parts of a circle. So basically, anything that falls outside of your circle is considered to be exterior. Anything that falls within your circle is considered to be interior. Anything that falls on the circle, basically on the line right here, is going to be considered to be on the circle, like it's on the circle. Okay, so it's exterior, interior, and on the circle. So next lines that we identified, and we did them right now in the warm-up, were radius and diameter. So radius starts from your center. It goes all the way to your circle. So it has the endpoints on the center and then on the circle. And your diameter, it's a little bit more specific. It goes endpoint to endpoint on the circle and also intersects your beautiful center. Okay. All right. Now, guys, I need a quiet, please. Thank you. Now, the next parts that we're going to go and define are chord, secant, and our beautiful line of tangency. We define that a chord is basically any type of line that has its endpoints on the circle. So this is an example of a chord. This can be an example of a chord. Another example of a chord. Another example of a chord. And so on and so forth. So yes, can it go through the center? Yes, it can go and intersect the center, as long as we have the endpoints and lie on the circle. Our secant, very similar to a chord. However, this time we have lines that intersect our circle, however, continue to go on in directions, in both directions. So we have our endpoints that intersect our beautiful circle and continue to go on both directions. Okay. Now, we also had special lines, guys. We had a tangent line. So basically, a tangent line is any line that intersects your beautiful circle. And that point where they intersect is called the point of tangency. Aaron, guys, Yanni. So, all right. So this is what we should be able to identify by now. So we know what a chord looks like. We know what a diameter looks like. We know what a secant looks like. A tangent line looks like, and also a beautiful radius. Okay. So all these beautiful lines are basically put into the circle. Okay. Now, let me go ahead and go through here. Now, today, this is what we're going to define, a chord again. So we're going to go ahead and focus on just the chord. So a chord, we said it was a segment whose endpoints lie on the circle. Now, from these points, here's my endpoint A, my endpoint B. I'm going to go ahead and create a chord. I can go ahead and also create another chord. However, this one is going to share an endpoint. The endpoint is going to be B in this example. Now, whenever that happens, the beautiful chords create what we call an inscribed angle. So an inscribed angle is basically an angle whose vertex lies on the circle, and the other points that are on the angle are contained within the circle. Now, here my inscribed angle, guys, it happens to be ABD. So I'm going to go ahead and label it as ABD. So here's my inscribed angle right here. And I'm going to label it as ABD. So here's my angle. ABD. Now, what's so special about this? Because the vertex lies on the circle. Inscribed angle, its vertex lies on the circle. All right. Now, what happens if I create more segments? What happens if I create 2 radius and happen to be on center? Those type of angles that are created then are what we call central angles. And the way to remember what they are is by looking at their names. Central, central, center, central, center. So central is going to be in the middle of our beautiful circle, right at the center. And this angle, basically, we're going to go and take its measurement, and we're going to go ahead and consider to be the smaller than 180 degrees, because we have 2 parts of our beautiful angle. We have the interior angle and the exterior angle. We want to look at just the inside of it, okay? So we want to make sure that it's less than 180 degrees or equal to, okay? Now, this beautiful angle is what we call ACD. So this is angle A, C, and D. Now, what's so special about this? Its vertex is where? On the center. So central angle, vertex lies on the center. Inscribed angle, vertex lies on the circle. Okay, so just to help you guys distinguish them from each other. Okay. Ready for your activity? Okay, so for person, you guys see compass and protractors. Go ahead and pass them back. So grab one per person and pass them back. And I don't have my person in the front. Grab one and pass that. All right.
1v1.
Okay, I hope everybody has tools. Does everybody have tools? Yeah, 2 tools. Your compass and your protractor. That's what you're gonna need today. So we're gonna go and construct a beautiful circle or beautiful circles. We're gonna go and construct a total of 4 of them with your beautiful partners with different diameters, okay? So that's our goal. We're gonna go ahead and construct 4 different circles with different diameters. Each of you guys are going to construct 4 circles. You are going to construct 4, your partner is going to construct 4. No, circle. Okay, now, within the circles, we're gonna go ahead and construct the following: a central angle, an inscribed angle, and we should have the following materials. We have a protractor, compass, pencil, and the paper that I supplied to you guys, right, for the notes. Okay, so everybody should have all those parts. Now, here are instructions with our tools, right? And this can be anywhere on your paper. It can be in the front, it can be in the back, or anywhere you have space in your notes. Keep it in your notes so you guys don't have to worry about losing your construction. You keep it nice and safe in your notes. So we're gonna go ahead and construct 4 different circles with different diameters or different radius, okay? So different sizes. Now, we're gonna use our compass to draw a circle. We're gonna go ahead and make sure we label it C. So everybody should have this tool, right? It's orange. Yeah, okay. Now, whenever we start constructing our circle, do you see that little middle part? Right there? That's going to mark our center. So whenever we place it on our paper, make sure you guys mark the center. It's very, very, very important. Yeah, let me go ahead and show you guys how.
On the back or front?
Either wherever you have space, you can do both. Either the back and the front. You guys want to do a combination, back and front, whatever, whatnot. Whatever you guys decide to do, as long as you guys do it nicely. Okay, let me go ahead and show you guys what we're going to do. So here is my camera. I should be able to see. Let me see. Okay, perfect. Okay. All right. So here is my screen, right? You guys see it? Okay, so pick a place on your paper. Make sure you guys have enough space for 4. Go ahead. When the pass returns, Alexander, I think somebody's out. Okay. So the first thing you're gonna do is mark your center. So mark it. Make it nicely and pronounced on your paper. Okay, mark it. Now, the next item you're gonna do is select your radius. So you can go ahead and choose either of the points on here. Do you guys see? You can go ahead and choose any of these points, or you can go ahead and choose any of these points. It's up to you, whatever you choose to do. These right here? Yeah. No, because we need a center. So no, not these. We're gonna draw a bigger one than those. Let's just go ahead and say that. They're too tiny. We can't see from those. Now, from here, we're gonna go ahead and select our point. I'm gonna pick right here, and I'm going to rotate it. So I can go ahead and create the perfect circle. It's beautiful. Look at that. I created a circle. Oh, pues. I'll start charging you guys for papers. Preferably, you guys do this with pencil. You're going to repeat this step 4 times. As you guys are repeating it, make sure you guys label your parts. You're going to go ahead and label your center. C. C for center. So go ahead and create 4 different circles with 4 different diameters. You can make them as big as you want, small as you want. For diameters? Yeah, like different. That's already in the wrong way. Yeah. I'm just trying to keep track of. Okay, should have 4. Let me check. Guys, so some of you guys are done. The next part, we're going to go ahead and draw an inscribed angle. And the way that we're going to go ahead and draw this is we're going to go use a straight edge, whether it's this part or this part of our tool. As long as you have a straight edge, you're going to go ahead and create your points, your chords, and bless you. And create an inscribed angle that is acute. Make sure that acute is less than 90 degrees. So let's go ahead and see. Here's my camera. Now, listen up, guys. I want you guys to look at this. So inscribed angle, you're going to go and pick any point. I'm going to go ahead and make this my vertex. And these are the points that lie on my beautiful sides of my angle. Now, I'm going to go ahead and label my parts. D, E, and F. So the way that I'm going to connect this is that I'm going to go and use my straight edge. And I'm going to create a chord from D to E. And I'm going to create another chord, however, from E to F now. So therefore, whenever these two share the vertex on the circle, I create an inscribed angle. Yes. Yes, for all your circles, 4 circles. So we're going to go and repeat this process for all 4 circles. So we're going to go ahead and create our chord D, E, and E, F, with E sharing the same vertex, or sharing the vertex at E. So we can go ahead and create an inscribed angle. You guys created an inscribed angle today. Woo-hoo. And it has to be cute, guys. So make sure that it's nice and beautiful. Make sure that these two are not that separate from each other. They're just like nicely done. Okay. All right. Go ahead and repeat that step for the 4 circles. Yeah. That doesn't matter if it's very similar. Yes. That's right. It's and make sure that it's an acute angle. Yes. So D and F have to be very close to each other somehow. You can make them closer. You can make them a little bit wider as long as this angle is not more than 90 degrees.
Just so everybody knows, this year our is gonna be a lot harder than John. Very big job.
Yeah, I made it up. What?
Okay, ready?
Yeah.
Okay, all right, next item, guys. We're gonna go and construct a beautiful central angle. Now, we don't have to construct any more points on our circle because our points are already constructed for us. This time, our beautiful circle or central angle is going to be from D to C and from C to F. So we can go ahead and have a central angle of DCF. So this is what we should have next. From D to C. We're going to go and use our straight edge one more time. And then in the same idea, from C to F. Bless you. So we have our beautiful inscribed angle. So what happened, Ms. Vasquez? So from D to C.
The compass.
And then from from C to F. The symbol that it creates, it looks very familiar, huh? Like you guys seen it before. Ay, Dios mío. Okay. All right. ¿Listos? So my central angle and my inscribed angle are going to be sharing point D and F. And they have two separate vertices, D and E. Let me walk around and see what you guys have so far. So my next step, guys, is to measure each of your beautiful angles. So we're going to measure all the inscribed angles and central angles, and we're going to go ahead and write down our data right on a table. So on the next slide, if you guys look at this right here, that's where your next or your information is going to be written down. So you should see your beautiful table like this. So we're going to go ahead and measure each of the inscribed angles, D, E, F for circle 1, 2, 3, and 4. And then the same circle. So for circle 1, with the first one that you drew, we're going to go ahead and measure the central angle, DCF, okay? Then we're going to go ahead and pop 360 and subtract the measurement of DCF from it, okay? All right, so let me go ahead and show you mine very quickly, how to measure. Very quickly, okay. All right, so if you guys forgot how to use a beautiful protractor. Now, remember that we had two scales, guys? My first scale was the inner scale. Then we have an outer scale. So we're out of focus. We're going to go ahead and use the one with 0. So we always start from 0, okay? Now, we have to align two things. The vertex of your protractor and the edge to your side of the angle. So I need to start measuring my inscribed angle. So I'm going to go ahead and align that right there with our vertex E. And I'm going to rotate it so that it's aligned with the side of the angle. So I have two things. My vertex aligned and the side of my angle aligned. Once I have those two things, then I can go ahead and start measuring. So here it is, aligned and aligned as much as possible. Now, Ms. Vasquez, which one do I use? 180 or 0? Where do we always start counting from? 0. So we're going to go ahead and start whichever one starts from 0. So 0, 10, 20, 30. And for me is 35. So this is 35 for me. You guys should have different measurements. Now we're going to go ahead and repeat that. However, we're going to go ahead and do that now for the central angle. So all you have to do is just slide your protractor up. Align again your vertex with the starting point of your beautiful protractor and just align the side. So again, aligned, aligned. So we have 0, 10, 20, 30, 40, 50, 60, all the way to 60. Let me align it much better. It seems to be 69, 68. I'm gonna go ahead and leave it at 69. So I have 69. So go ahead and repeat that same procedure, guys, for all of your circles, for your first circle. You're gonna go ahead and measure the inscribed angle, which is this part right here. Inscribed angle. Measurement of angle D, EF. And your central angle. Measurement of angle, okay, you can see it. DCF for all angles. Okay, so central angle. And inscribed. All right. There you go. You guys see it there, much better. There you go, much better. I'll be walking around and let's see what we got. Let's go ahead and write down some information that you guys have. So I'm gonna go ahead and write mine down first. So let's see, we had 69 for angle DCF, and we had DEF. What was our measurement? 35. Now, if we had to subtract DCF from 360, we have 360, so therefore we go into 291 degrees. Okay, all right, so 291. Okay, perfect. So let's see who's done. Who has one at least done? All right, Josue, what do you have?
My first one?
Whichever one you have done.
Well, for my second one,
Oh,
for the, right?
Inscribed angle, yeah, that's the first one.
Oh,
it's minus.
that's me.
28. Your central angle is 51. And 360 minus 51. 309. So this is 360 minus 51. This is 9. We borrow 1. So this is 9, 0, and 3. 309. Okay. 309. All right, let's see who else. Catherine's ready. I ready, Catherine. In the back. Give me one of your measurements. Doesn't have to be circle 3. Anyhow. 43. 85 and 275. Woohoo. Okay, let's see. Who else? Who else hasn't participated yet? Either Nelson or Nelson. What do you have as one of your measurements? 21? 40? And 40 minus 360? There you go, 320 degrees. All right, let's go ahead and analyze what we have here very quickly. What do you guys see? This is my inscribed angle, DEF. It's the long one that is computed from the quartz. What do you guys notice as measurement? 35, 28, 43, 21.
They're all one.
They're cute, right? They're all small. Now, compared to the central angle DCF, 69, 51, 85, 40. The measurements are what? Larger, but how much larger? Let's go ahead and say we had to double this measurement. 35 times 2. It would be what? 70. Is it close to 69? Let's go ahead and do 28. 28 times 2. 56 is it very close to 51? What about this one? 43. 86, is it equal to 85? And what about this one? 21. 42, very close to 40. So what do you guys identify? That they are going to stubborn measurement. So that's what we're going to go ahead and stop it right there. We're going to go ahead and stop it here. We're going to go ahead and continue on tomorrow.